Okay, yeah, so the presentation seems to be working. Welcome. Thanks for being here. It's really very nice pleasure to be here. So we are gonna talk, as we say, about the analyzing the royal candy and how King manages its data. Some background about me. Maybe he said something about that. I didn't understand Polish, but I have been working more or less for 15 years in the computer industry. Working prior to King, I worked for H&M, selling clothes, retailing online, and then I worked for IKEA, selling furniture. I'm very Swedish, I would say somehow. And here we have Mattias.
So, hi, my name is Mattias. I worked about 12 years with data, 4 years with clinical trials data, and then 4 years as a business analyst, analyzing poker network and also doing web analysis on traffic. And since 3.5 years, I'm with King, working with analyzing game data and building data warehouse and all kinds of things. Should I have this? So, about King. We make great games, or we think we make great games. On the Midas Players site, we have more than 195 fun titles played in over 200 countries around the world. We have 356 million monthly unique users, and we have studios all over the world. Most recently, we acquired Z2 Gaming in Seattle, which we hope will provide awesome King games in the future. We also have small offices in a lot of other places in the world. More about King. We create our own game concepts, and we try to build really strong brands and franchise. We develop and design and publish the actual games, so like we do everything internally. We market and sell it directly to the players, and we cooperate with social graph providers like Facebook, but we have also cooperated with Kakao and a few others. And we publish our games through, well, both our own website, king.com, but mostly on Facebook and, iTunes, App Store, Google Play Store, and a lot of other places. So, the thing we're most proud of is we invented this concept with games called a saga game, where you have it like a puzzle game. This is Candy Crush, and you have you can play a designed level, you get 1 to 3 stars, you progress to the next level, but you can also see the pictures of your friends, and your progress is stored, especially if you're Facebook connected, your progress is stored across all devices. You can play on, Facebook in a browser, you can play on your iPhone, you can play on your iPad, and, everything is seamlessly synced across all platforms, so you can continue where you left off, which is really nice. So, King was founded in 2003, and originally the games were available through our site portals. So you could play on king.com, but also on Yahoo Games and America Online. That business idea became a bit stale. Yahoo was dipping to basically declining a lot, while Facebook were up and coming, and Zynga had taken the entire Facebook market. And we were in a pretty bad shape around 2010, 2011. But then in Q2 2011, we launched our first Saga Facebook games, and that went really well. And then a year later, we launched our first mobile games, and that went really well. And some bragging alert then. So this is Alex Dale, our head of marketing, when we launched Candy Crush Soda Saga. And just to show what we are right now, Candy Crush has become like an internet phenomenon, and people are making memes and talking about it all over there. And most recent thing was a Spanish member of parliament was caught playing Candy Crush during a speak to the state by the Spanish prime minister, so that is all over the news in Spain now. So we're really becoming something, or we have become something really big and all over the place. So where are we right now? This is top grossing iPhone apps. I just pulled the numbers in the App Store from 6th of February, so it's a bit old now, but...
Actually, it's games.
It's games, yeah, games, top grossing game. And we are there, and there on the iPhone App Store. And on Facebook most popular games, we are all over the place. So we have been we're really happy that we became this successful. But when you become this successful, you actually, most people working in technological companies know that, having this many users might not be too easy to, scale and deliver content to. And Jakob is going to tell us a little bit about how we set it up at King.
Yes, so a bit more on how our server setup is. It's fairly straightforward setup, you can say. You play either on your mobile or on Facebook. We call it Canvas because we also play on, for instance, King.com site. So we see them as two different parts. All our servers are located in Stockholm. We both have in North Stockholm and South Stockholm, actually. But and for the moment, we don't need to have any distributed of our game servers because most of our traffic that is coming to our servers are asynchronous. Only we send them. You play a game, we send data when we can, so you can play offline also. Purchases, of course, that might need some synchronous communication. So there are some features that we need. The setup, we have databases. I don't know how many, a lot. It's MySQL databases, but we don't use them as a traditional relational model. We use it as more of a key value storage. So we have a key, we have a value, we have shards, and we just you don't do any relational foreign keys and stuff like that. You can do it, but we don't use it because it's prohibited. We have what you don't see here. We also have a memcache cluster with about 4.2 terabyte of data in between. I think it was 12 machines split up. We can change here a bit. And here is a bit about the volumes we have as average on our app backend servers. About 250,000 requests coming in on average, which multiplies up to 1.8 million reads per second, because we have to fetch different parts of the data from our data storage. Yeah, and you can see it multiplies over. This is also without any CDN information. It's content delivery network. You might have heard about Akamai, and we use similar technologies for caching up JavaScripts and images and Flash files for Facebook. So this is core request coming down to our Java backend. We are going to focus more on the analytics side here because it's a Hadoop conference and analytics. This is the traditional setup, I would say, of when you look at analytics. You have the same traffic comes into the game servers. Then you have a bit of competing between the game data that is that we need to serve the state for the user and stuff like that. And then you have if you say the red bucket there, and then you have the orange bucket is more okay, we need to do reporting. Okay, so we need to fetch data somehow, and how they compete about the resources. So for us to be able to mitigate this problem, we have separated it completely. the game data is more or less off limits for anything that has to do with reporting. We have an event stream of data, and we save that that comes into our data warehouse environment anyway. So all analytical will be done there. I think I have more on. Oh, sorry. Yeah. So if we look more on the analytical side, we don't touch the database. We have an event stream of data. The data is then sent to different parts. We send the data into our Hadoop system. We have a Kafka for like what you say, the real-time analytics. We have, of course, some external providers sending us data like we need currency rates, we need App Store information, Google, Kakao, Tencent. They have information about the real payments. We track, of course, this one also, but that data needs to come to us also. What is happening now, more stuff is doing analysis on the Kafka stream. More and more people, we see that our Kafka cluster is way too small, so we're going to double it up right now because that's where most of stuff going. And to talk a bit about what we're using right now in our tech stack, and we want to say right now because it changes quite rapidly from time to time. We have Hadoop, of course. Servers are running Debian. Exasol is an in-memory database that we use for as query layer for a subset of data. Ad hoc analysis, a lot of KPI reporting is done there. It's really fast. We use one recent thing we added right now is Cassandra. That's, I think, I would say the newest thing we have in the platform right now. We need to do some segmentation of data. We have some Mahout for random forest and prediction algorithms. ClickView is used for our reporting side that we produce for people. We are using Jenkins for scheduling. We have used Uzi before, but right now we have moved to Jenkins. What more? Microsoft. You wanted Microsoft, but of course,
yeah,
Excel is a very powerful tool in a way. So we
use Excel a lot and PowerPoint.
Oh, sorry. So this is what we call the events or the event stream. It's fairly. This is actually how it looks. Almost real, maybe a bit faked, but go to the next slide here. I think it's better. This is how we call an event. You can see we have the timestamp. This is produced on all log servers. We produce them for everything, and you have an app ID. 17 is actually, I think, Candy Crush. And then you have the event type. This is dictate how the actual data in the stream is encoded with metadata. This is governance of metadata. It is very, very important for us because everything is produced from this. Yeah.
So this format is a bit interesting. People have been asking why don't we use a binary format like Avro or something else to send the data. But we are really fond of like being able to tail the log with a Linux command line tool and get it. So that's why what we have here is basically ASCII tab separated text file. So it's really easy to just fetch the fields you're looking for if you're debugging a web server or just looking for something. You can really ad hoc use these events with any tool, which I think helps a lot in getting the data and make it so that all the developers can easily see that they are building the right events and producing the right data that we want as well.
Yeah.
So there's lots of advantages, we think, for using this kind of format.
Yeah, and as I said a bit before, the logs and event transportation, as we are fairly close to our servers. We don't have any distributed, so we more or less we rotate our log files, so we transport them at the moment both on Kafka and on raw text files, gzip files. These are synced and SCP'd into our data, into Hadoop and to our other systems that we need them. Fairly basic. We don't have any real problems because we don't have any distance, more or less. We have very, very high. And the queues are used for real-time system. We'll show a bit more about that later in the presentation, and some anomaly detection. And even more systems start using this within the King. Yeah. So a bit of a repeat, but the environment for the game backend is like isolated environment. We don't touch that. The contract between us, with game servers that produce the games, the events, is called King Constants, actually. Funny name. And that's the metadata that actually describes everything. An event has to be immutable. So if you have created it, and one event has been fired on this, you can't change it. It's there forever. And that happened fairly many times, that they've created it and just discarded it and deprecated it directly and stopped sending it. But it's still there, so we have to keep it. I think we have over 600 events. I did a check, but then I did a check also to see how many are active, and it was like 300. This was like 1-2 months ago. But it's basically that. But for a data warehouse, every event is more or less, all historical versions of events are important, because if you want to do any reruns of anything, this will, you must be able to take into account bugs and everything. And of course, there are bugs in data reporting. We have that all the time. Should be also like that. And yeah, everything that goes into our Hadoop, we never delete anything. We save everything, because you never know. I think it's a bit classical, but you don't know what to analyze tomorrow. And that happens a lot, I think. And we have to rerun. We thought it was like this, but it wasn't like that. Yeah, and we in data warehouse, we refine data structures, dimensionals, facts, and try to make the data structure more suitable for the people who are using the data. And that's basically what we do there. A bit about volumes. That's always fun to see. I think we have we're up at 2 petabytes right now. It fluctuates up and down based on what we do. Our configured capacity on the cluster, Hadoop cluster, is by 2.5 petabytes, 162 data nodes. We have 300 to 400 gigabytes compressed log data every day. I think it's actually higher now. It's more now, because we did some calculation with like, it comes a bit more. 15 to 20 billion events per day. I think that's even also low. Actually, it's probably up a billion or two, I would say. 250,000 events per second. It's the average stream. And we have about 100 people, data scientists, data warehouse people, some business performance manager, developers in the back end wants to know how their games are using our systems to analyze how the system works. Over to you.
So just to kind of see how it was like when I started King somewhere in the middle of this chart, which I call early days of Facebook. And just to give you an insight on how it will look when you're working at a company, we're using Hadoop. So this was the early days, and this is the chart, which doesn't have any accesses because, well, it's not really important. Just shows the event volume we got per day. So this is very early. And around here, up until that point, we actually loaded all the raw event logs straight into ClickView and built the reports with ClickViews in memory. And around this time, ClickView basically says no, or our ClickView installation can't ingest all the data again. So I've started working like a month earlier than that, and together with a friend. And he set up a Hadoop Hive cluster, but that wasn't really ready at that time. I set up an InfoBright MySQL storage engine, and we loaded the data into that. So we started using Infobright to do the analysis. And this is a little bit later. I'm not sure if you can see, but that was the old chart. So we thought we were growing a lot, but then a little bit later, it had increased a lot. And around here, we move from Infobright Community Edition, and we have a Hive cluster set up. And sorry. So we got a huge data volume increase. And, well, some time passes, and it grows even more.
Just to understand, the blue one is web, like Facebook data. The red is mobile.
The red is the mobile data we get. And that was the old chart you saw, which looked like it was expanding a lot. And it grew even more. And then we need more nodes. And then, in recent times, it has grown even more. And I think this is the case, because this is two developments. As a company, you're growing, you're getting more successful. Most companies will probably not be as successful as we were. But still, even if you aren't successful, data is growing just because you're adding more tracking, you're adding more features in the games, you're adding more things. So you should assume that you will always be growing. And the only reason we could grow like this without any severe growing pains is just that from the very beginning, like from these humble beginnings, our CTO was always saying, like, think times 10, think times 100. We're going to be 100 times bigger. Make sure you can scale for 100 times bigger. And I think this is a very important lesson, because I've been at companies before, this poker network I was working for and some other companies, where you're basically in a situation that, yes, we can grow, we can sell more. It's just that we can't scale our solution to that. So we have to say no to customers or no to business opportunities. And you should always strive to, look at, what is the best that can happen? Yeah, it's this, that you're growing to become huge. And you should make sure that you can scale out your solution so that you can live with that. So we've grown a lot. What are our problems? Well, we don't have any problems. Just kidding. We're trying to join 20 terabytes in a stupid way. And this is we have a lot of challenges. Growing the data volume like this has been, immense headaches. You'll have to rewrite the jobs. You'll have to, buy more nodes. You'll run out of, network there. You'll run out of memory there, and you'll always have to be on top of the situation. So we can talk about the challenges with our data that we have, especially at King. And we can't have a persistent key for a user, because we are not forcing login when you start playing Candy Crush. You just start playing. But then it can turn out that you're actually some other player that already played the game for several years. But that can turn out to happen like 5 weeks later. So we always have to look at, like, what we think is a user might change in the future. Well, unique key for a device, well, we can't get that because we're prohibited by both Apple and Android to fetch a device identifier. So we can't identify a unique device. We're also a very agile company. We release a new version of the game every 2 weeks. That means every 2 weeks, there's a new chance to get a few bugs in. Well, there's also a chance to repair the bugs, so it has advantages, but it means that you'll have to be on top of things, repairing data, making fixes. And the last point.
Comment there is like every 2 weeks, every game releases every 2 weeks. It's not like, so there is almost a release every day.
Yeah, so for each game, there's a release every 2 weeks. And also the Plataforma, the actual backend, is super agile. They basically, each commit is a release because they don't know when a game team will pick up the new version. So, and the last point is basically the fact that, data from internet or from people's devices, somebody has a jailbroken phone, where they're doing some shady things, you can always get strange data into your network.
Some very interesting Chinese devices that have, before we actually had MAC addresses or something like that, every phone sent the same MAC address. So the Android devices are
Yeah, Android devices from smaller are a bit strange. Yeah, so our other challenges is, of course, data volumes ever increases. Big data systems are not as polished as you want them to be, sadly. It is bleeding edge technology. And our daily users are used to databases. When I say our daily users, I don't mean the gamers, I mean data scientists and people working with data. They're used to working with something like SQL Server, and then you set them in front of Hive, and it doesn't really work the same way. We need to run queries of the complete database in reasonable time, which is heavy. We need to quickly find problems in the data stream, the bugs I was talking about. We need to be more data-driven, analyze our own systems to optimize them. And we have an issue with the fact that we have an event model, and then we use a lot of Hive, which is a relational language, and they really don't map too well together. So I want to talk to you about funnels, which is something with regards to these event streams. It's usually when you have an event stream like this, you will have an event saying, oh, well, here's a user started a game, a user ended a game, a user purchased a product. Usually have a relation, but it's not like a SQL relation. It's more for each event, I probably want to know what happened the event before. And you can't join and say on the event before of that type. There's no such notation. So what you usually have to do is, well, you can do a non-equi join if you're on SQL Server. You can probably do like where timestamp between these two and do the join on user ID equals user ID. But on Hive, that is prohibitively expensive. So you have to use a custom reducer, arrange the events in order, and then basically build a state machine that keeps the old event, and then when it gets the purchase event or whatever you're looking for, it emits that and the interesting tidbits that you want from before. But also you can build a funnel saying like, I want to know out of the people that opened the application, how many continue to play the game, how many did that. So you have that relationship as well. So within King, we have made our own way of describing these relations. And we can then build the same funnel to have in real time as well as in batch. And we can show it, flip. So this is some examples of what we try to do within King with analysis. So this funnel, for example, I can read loud because I saw the text was a bit small, but it's basically just start of the application. Then the second step is, did the HTML page load? Third is, did the Flash load? 4 is, did the application code actually load? Fifth is, did they start the game? Did the level load? And did they actually finish the level and successfully did it? So this is just like a very technical, can they actually play the game kind of thing. And this has been fairly successful because we can define a set of events like this that should happen in an order. And then we can have a chart which is run in batch, where you can look at history, and the left below chart is supposed to be per date. But then we also have a real-time chart that shows us over the Kafka stream how many people every minute that goes through these checkpoints, which helps a lot in getting that bug fixed that causes the players not to be able to play the game, to pick it up immediately after release and fix it as soon as possible. So it's a very strong advantage.
Yeah, and one of these systems that I'm going to talk a bit about some of the systems that we use for analyzing understanding how our game performed in real time, because it's very important that we noticed. It's we use these systems for like game performance and latency. These systems show the latency of 1 minute on all games we have, so you can have a view, and we have this on large screens on all offices more or less, so we can see that somebody released, we see a big drop in game starts, for instance, maybe a bug in the game, or is it a bug in the server, but this is the first point of contact to actually understand that something is happening with the game or something is going bad. Operations use it when they do any network fixes. We see the performance if we turn on some more. Yeah, I'm gonna send some more messages or I don't know if you have ever gotten a message from Candy Crush on Facebook. I don't think so. But, no. We see transactions and revenue in real time here. It's very powerful for us to see. The same data is more, have we also added anomaly detection system, so we can actually see the anomaly. This is then mailed to you or sent on our internal messaging system called HipChat. It's a company, a US company, I believe. That is.
Yeah, and the graph library, if you like the style, is matplotlib for Python with XKCD style. I think it's really nice.
Yeah. And it is really powerful. We can see that if something changes, you get a lot of mails, or then you can have like targeted per this game, or is it an app we have? We can see that, so we get drop in transactions on Candy Crush. What is happening? You get an alarm on that, and you can then go in and drill down what could be the problem. Is it the router that's failed, or is it the game server that is doing any problems? Change slide. Then we also use open source product called OpenTSDB. It's running on the Hadoop cluster with the HBase. It's a time series database. We use it both for server monitoring. All our Hadoop nodes is running have a collector of data that we measure network, CPU, I/O stats of the hosts, and we then can do a graph on this and compare different charts, network, I/O, and different hosts. And that this is like, I think this is like CPU and I/O stat on some machine, and just to see the differences. The colorful down there, it's maybe not the most visual one, but that's the event stream data that we can see how many events per game we see, and then we can drill down in the event data also. So,
if I had some time, I can share some Hive tips and tricks. I was thinking. So, just wanted to. I'm not sure. Do anybody use Hive in this room, or already use Hadoop? Okay, so this is mainly directed to you. This is 2 convenient things I haven't found on the internet that I thought I'd share. And it's just. I've been using the Hive complex data types a lot, and this one is one of my favorites. Named struct can be used to get the first of something. So this is a classic problem for us. For example, for a user, we want to know the time, what was the first level they played in the day, or the last level they played in a day. But you want the actual level identifier. Then you can use the named struct to just, fetch the data once, do the min of the named struct of the timestamp and the level, and then you can get the first level while using just the min function, because the min function will get you like the lowest one on MSTS. The sort function will sort integers as integers and strings as strings and do it in the order you see. So it is a convenient way to get the first, the attributes of the first thing without writing a custom reducer, which I think is, fairly nice. I've seen a lot of people write custom UDFs to get this problem solved, like what's it called, rank functions and things like that, but I think this one is much more convenient. And the second tips and tricks is to start using the collect set function, where you can collect all the attributes into an array. So this query is just an example. I want to, fetch for each user, I want to fetch if they didn't play Candy Crush or Farm Hero Saga in this example. I can get the set of users that didn't play those 2 games, which would require several joins if I tried to do it in a normal way. But with this, collecting all the set and then asking, do the array contain these things, I can fetch it in one go. It runs as one MapReduce job, and it's fast. So that's some tips and tricks for you.
Yeah, Matte has a lot of tips.
Yeah.
Catch him later if you need high information.
So this is your opportunity to quote Reddit. We work at King. Ask us anything.
Ja podejdę z mikrofonem. I have a question about comma-separated values or tab-separated values. You do realize that there are formats like RC file, ORC file that are 10 times more efficient, 10 times more storage efficient in Hive.
Of course, this is what we have on the raw log files. Then when we import them, we have them on RC file right now, and we're investigating going to ORC or Parquet for that. But when they are in Hive, they are in RC file. And this was just the raw. We transformed them when we import them into Hive.
So this is how they are sent from the web server. So as I said, the biggest use for why they're tab-separated text files is because they're really easy for anybody to work with. And all the developers can use Unix command line tool to tail the logs on a QA web server and get the information they want.
Jeszcze jakieś pytania? Tutaj dwa pytania widzę.
Could you say something more about hardware and infrastructure of this, which handle this lot of requests? Hardware and infrastructure.
I don't actually know the hardware of our web servers and database servers.
What
do you mean that, like the?
What's the hardware setup?
Yeah, I don't know.
I think there's an F5 load balancer, which is incredibly expensive. Then it just fans out to like several hundred web servers. But all those web servers are fairly straightforward, normal, your run-of-the-mills, 1 unit or several unit servers that just handles response. But it's basically just about we're having a lot of web servers, and it's not like each web server is incredibly efficient. It's just that we can just stack more web servers. I'd still think
they are efficient.
They are efficient.
I think they're up to 3,000 requests per second on each server or something like that. So.
But you can probably see somebody with a white paper, in academics that can handle, several 100,000 requests per second on a server. But we're happy with the 3,000 and the fact that we can add more.
I think the hardware is Dell-based, fairly simple, Debian-based. I don't know the actual facts. Database servers are, of course, bigger with SSDs and stuff.
Yeah, they run solid-state disks and have lots of ROM, and they're much better. They are a bit special, and we had to turn out the green thing from most of our servers because they on the database servers.
Everybody does.
Yeah.
Bardzo proszę.
I have a question about architecture on slide 17.
Yep.
And there is a Kafka flow and Hadoop flow. This is separate.
Yeah.
And
at the moment it is separate.
So is it any reason to separate this, or do you plan to combine the Kafka flow into Hadoop also?
We're discussing a lot about Lambda architecture and see if we can combine this.
But the basis right now is, I think we didn't have Kafka when we first built this, and it's just that Hive queries have a lot of latency, and it's not in Hive we don't need data more often than once an hour. Like that's very sufficient for our needs in Hive, and this has been working fairly flawlessly. So people are a bit, and with Kafka, we still fairly recently had a problem where we moved from Kafka 7 to Kafka 8, where we had like a drop in communication, and we really don't want to investigate, or we haven't investigated the resources yet on how to make Kafka like a fully 24/7, we will never lose data service. But with the hourly log rotation, we don't lose data, and we haven't lost data in a very, very long time. So we're not really keen on rewriting it because we don't see a strong use case. But we would rather build, so with the Kafka stream, we will probably build a micro batch that loads the data into Exasol, which is our query layer. But right now, when it comes to, I know I mentioned Lambda architecture, but the most Lambda we have right now is the fact that we can use the same definitions across both Kafka and Exasol, but we don't have that nice thing where you can write a query and it'll fetch the batch data there, and then it'll fetch the real-time data there and kind of give you seamlessly in the same interface thing, sadly. But we'll work on that in the future.
We haven't had any major problems with log transportation.
Tu było jeszcze jedno pytanie. Ale to będzie ostatnie już, bo czas nas wygoni.
Okay, last question. Are you working with some public cloud solutions, for example, AWS, or maybe you have some private cloud?
Right now we have everything our own hardware. We have some. No, that's not correct. We actually have stuff running on AWS also, but we don't have any private clouds. Maybe we have some kind of piston head solution, but that's more for development and QA cluster. QA, not for the Hadoop stuff actually at all. But we have AWS for some specific systems that need to be close to other
Amazon cloud-based systems.
Other Amazon cloud-based systems that are not in our, we don't know. Like.
But we try to build almost everything on our own hardware, and I think it's given that we're a freemium game, your average user we will earn nothing from. So in that sense, I don't think we can pay to host for all the users, because then we'd get into a situation where we had to have much more aggressive paywalls, because we would have to earn money because we'd have to pay for much more for the servers. So I think it's for a freemium game it makes much more sense to try to host as much as possible yourself. You also get the competence within house to host things, which is nice.
They are evaluation of see if some stuff might be better to run on AWS actually. So you never know what will happen in the future actually. So
Okay. So thank you very much for this excellent presentation.
Thank you.
Thank you.